Hello everyone, welcome back. I hope you're doing well. The last 2-3 weeks have been crazy. Loads of work in real life, but also I had to clean my old apartment, which took a few days. But now, let's continue our game by making the collision more accurate. Let's go. Just a quick reminder, all of the code I cover in my videos can be found on GitHub. Each episode will have its own branch. There's also a Discord server for this channel. Come in and say hello. If you wish to go the extra mile to support my work, you can do that on my Buy Me a Coffee page or becoming a member here on YouTube. Links can be found in the description below. Why don't we begin by checking our current state, like we always do, and see what the goal of today will be. So last episode, we should have some sort of collision. It's working, it's detecting the walls, but it's not detecting corners very well. So if I go down here, accidentally moved outside, here we go. I shouldn't be able to be in here. That should be a no-no. I can't go in completely, but if I go sideways, it might allow me to do it. So yeah, that's what we're gonna work on today. So the idea is that we're checking each 4 corners of our hitbox and then checking if any of those corners overlap a solid tile or not. If there is no obstruction, we can walk there. If there is something there, well, then we can't walk there. And it's going to be checked for each corner, each update, or each move, so to speak. So let's begin. In our playing, in this update player move, we have all the code currently for checking the position, and if we are facing to the left or to the right, we apply the width or not, and height or not. But we're gonna check all the corners, so we will not need this. We will not care about this position, X position check, Y position to check. But we're going to do something similar. We're going to take the position of the player. So we're going to use the entire hitbox because we're going to all corners, not just the left one. And we're going to use the camera and also the delta, but we're not going to use width. So we can comment this one out for now. We're going to have here if we can call a method with the same name, that's fine. Can walk here, but we're gonna give it the player.hitbox. Then for X and Y, we're gonna need a camera and delta, so we can just copy that. And for Y, we're gonna take the same. Is there something else we need? Yes, we need a map manager. So map manager.getCurrentMap. So we can use that. This is hard to read. Delta X is the speed, but then we have camera, so float delta camera is equal to X, just to make it simpler. Camera X times -1 plus delta X times -1. And I think we could remove this -1 and this -1. I'm gonna keep it for now, just to make it look as similar as possible. Delta camera Y equals camera Y times -1 plus delta X times -1. And then we of course can just say delta camera X and delta camera Y. That looks better, and if that is true, if we can walk there, then we do the same. Camera X plus equals delta X, etc. So now let's just create this method in here. And I'm gonna keep it, below, I think. Below this one, above is tile walkable, because we're still gonna need this one. So let's just copy this entire one, paste it, and not float X, but a rect F hitbox. Float X, float Y, no, but float X, delta X, delta y. Yeah, that looks good. I think we can move to one Java class per page. Then we need to change these two sections. The first one is just checking so we're not below 0, outside the bounds, and the second one is checking so we're not above the bounds. And we can remove it because we can see it up here how it works. But we want to make sure that if we're going to start with below 0, so we're not outside the bounds on the negative side, by saying hitbox.left plus delta x is less than 0. So this is the left side of the hitbox plus the change in x. If those two are less than 0, that means we're outside the bounds. And you can consider this being a negative, so maybe we're 100, then this is 101, we're outside. So we should return false. But we could of course have more. For example, we want to check the y as well. So, or hitbox.top plus delta y is less than 0. 0 maybe, yeah, like that. If that is true, return false. So we can check those two in the same line. It doesn't take up too much, otherwise we would have to have a if, else if, else if, else if. But now we're going to check if we are above. So else if hitbox.right. So we're going to start with the x as always, plus delta x is more than or equal to, what did we have? We had Gamemap get map width, return false, and we also need the one for if we are below, so bottom. So hitbox.bottom plus delta y more equal Gamemap width, no, but height. Return false. So this is doing the same as this, but since we don't have a specific position, we need to check the very left, the very top, the very right, the very bottom in all directions. Then our next step is somehow to replace the position. Here we get the tile position and the tile y position by using the x and y. But we're going to have 4 different positions, so we need 4 different, well, tiles to check, or possible tiles. So we're going to remove this, and we're going to store all of that in an array, and it's going to be a point array, and it's going to be for 4 points, alt enter to import, yes. And we can call them tile chords is equal to some method that returns the tile chords. And then of course with the tile chords, we can now get the sprite ID, etc. But we're going to start with the tile chords. And instead of just doing for 1, we're going to do it for 4. So we might as well make a method here, get tile chords. And this one is going to ask for the hitbox, delta x and delta y. Create the method, yes. And we can make another point array here. Is equal to new point, and of course it's going to be 4. If we take a look at the rectangle, we have 4 corners, and we're going to focus on the left, top, right, and bottom, and then we can build top left, top right, bottom left, bottom right. So for example, the int left one is going to be equal to hitbox.left plus delta x. Now we have the hitbox left side, but in pixels. But we will need to divide this and also recast it, but we're going to divide it first. Divided by gameConstants.sprite.size. So now we have the coordinate system in tiles. But we also need to recast this one to an integer, because we can't have 4.5 tile or something. It can be tile 4 or tile 5. And right is equal to, we're gonna copy this. It's gonna be right. And what else do we have? We can copy 2 more. Int top is gonna be hitbox.top, but not delta x. delta y, copy that, paste that, bottom, bottom, left x, right x, top y, bottom y. Yes, that's perfect. And now we can build our tile coordinates. So 0 is equal to new point, left, top. Tile chords 1 is equal to new point, right, top. You know what? We can probably do it like that, and then left, bottom, right, bottom, 2, and then of course 3. And then we return it. So we create a new array with 4 different positions or 4 indices. Then we calculate the position of left, right, top, and bottom. So we get that in tile values. And then we build our tile chords here. Left top, left bottom, right bottom. And then we return it. Yeah, that looks right. And now, next step is to replace this one, int tile ID. So instead of just having one tile ID, now we're going to have 4 different ones, and then we're going to check if all of those tile IDs are solid or non-solid actually. If one of them is solid, then of course it's not going to work. But first we're going to need a tile ID for each of these tile chords. So we're going to replace this one with yet another array, this time an integer array, because they are simple integer values. So int, what can we call this? Tile IDs with an S equals something. Get tile IDs with a S on the end there. And this one will need tile chords. And of course it will need the game map. So we get the game map type, so we know what IDs to get. So let's go ahead and create that method. Tile IDs, yes. This is going to be a simple method. We're going to need a integer array to start with, equals new integer with 4. 4 different values. We can actually, because what we want to do is to do the same as before. Where do we have it? Game map, get sprite ID with the tile X and the tile Y. For this method, we already have now the tile coordinates, but they're in an array. So we're going to loop through that and just return each tile ID for each coordinate. So that won't be too difficult. What we do is a for int I equals 0. I is less than tile IDs or tile chords dot length. Sure, I plus plus. And we can say tile IDs I is equal to not tile chords but game map dot get sprite ID tile chords I times x or dot x, or to get the x coordinate, and then of course tile chords I dot y. So this one is, we can copy this, is the same as this one. But now we're using an array to get the x and y. Here we already knew the x and y from doing it here. Removing that so we don't get an error. So it's the same, but now we get a list or an array of different tile IDs. And then of course return tile IDs. And I think that's all for this method, is it not? Creating the array, looping through the tile chords array, doesn't really matter which one. And then of course using I, so it's 0, 0, 0, 1, 1, 1, 2, 2, 2, and so on. Yes, that looks good. And now the last one is to remove or change this one. Is the tile walkable, tile ID, and that. If we take a look here, is the tile walkable? We give it a tile ID and a type, and it returns either true or false depending on whether or not it's walkable. We're actually going to use this one, but we're going to call it from another public static boolean is tiles with an S walkable. So instead of taking just one ID, we can take several. So int tile IDs, tiles, and tiles type. Yes. And now we have a array, so we just loop through it for int I equals, no, we don't need to do that. We can use a enhanced for loop. For int I, then tile IDs, and we want to call this, but this is always going to return true if it's walkable. So we can't just go return is tile walkable and I and tiles type, because then this will only loop once and then return whether or not the first tile is walkable. So we need to make sure that this returns true, this method, if all of these returns true as well. If one of these returns false, then return false. So how we do that is by saying if not any of these are true, so is tile walkable, I tiles type. If any of those is not true, then return false. I think that looks better, yeah. We're iterating through it. It's checking if any of those is not true, or the first one that is not true, then return false. If all of those returns true, this one is skipped and we return true. We can walk there. Yeah, so is tiles walkable? Tiles ID. That's all we have to change. And we're using most of the old code, but we adapted it for multiple checks in the same time. And this is going to be interesting when we test it a bit later, if it works or if it does not. So checking if we are outside the bounds. Let's say we're inside the bounds. We get a tile coordinate or tile coordinates for each of the 4 corners in this method right here. Creating the array, the 4 different positions, creating the 4 different coordinates and returning them. Then we go up here and we get the tile IDs from each of those coordinates with the game map. And that's in here, creating the int array, iterate through it, and we're getting the sprite ID from the coordinate and return that. And then we pass along these tile IDs into this one that goes through them. If one of those tile IDs are not walkable, we return false right away. And we come up here, then we return whatever this returned to playing. So if it returns true, we can walk there. Then we do the same change as we did before. We can probably remove this one. We're gonna keep this one for now. And we're never gonna use that again. I don't think we can remove that as well. So hopefully this will work. Let's check. Fingers crossed. Gradle building didn't crash. Can still move around. Let's just check this level if the bounds check works. Yes, I can't walk past that one. Perfect. How about the top? I could walk past it just a little bit, I think. Yes, I see it's outside. And if I try to move back, it's not letting me. Why not? Ah, here we have an issue. In our playing, delta camera y equals the camera y times -1 plus delta x. That's not true. Or it's true, but it's not correct. Let's give this a try again, because even if that was not the problem, that would cause a problem later down the road. So let's go straight up. Let's see if I can sneak myself in. No. What about I can walk down straight away. Perfect. What about left side? All right, let's go in and see bottom and right. So I can get in. I'm colliding a lot more now at the entrance. Let's see going down. I can't move into it, but I can leave it right away. And to the right, I can move into it, but I can't, but I can leave it right away. All right, let's see. Yeah, that's a corner position. Like here I could move up into the wall. I can't now, but I can move up. So yeah, our collision is far more accurate than before. Alright, that was how to make our collision more accurate. Next up is to make our player be able to slide alongside the walls. Remember to subscribe and like the video if you enjoyed it. More videos are to come, you don't want to miss that. Take care now and have a wonderful day. Cheers!